Welcome back to the part 5 of the Runtime Fabric series. In this video, I'll be explaining the app deployment flow followed by a demo. To understand the total agenda for this video, you can always refer to the video timestamp which are placed in the description below. Let's get started. Whenever you deploy an application to Runtime Fabric, there is a flow involving multiple steps that gets executed behind the scenes. Here are the members participating in the flow. The user, that is us, Anypoint Platform Control Plane, Agent, Ingress, Kubernetes, Image Repo, also known as Private Docker Registry, Resource Cache, and Registry Credentials. By now, you should be familiar with all of these participants. So as a user, I would log into Anypoint Platform, open Runtime Manager, select the RTF target, give the app a name, select the jar to upload, and click on Apply. The moment I click Apply, the flow gets initiated. The first step that the Runtime Manager UI does is that it uploads the jar file to Anypoint Exchange, and this is the point where most error occurs, especially when you are new to RTF. The common error that occurs is the group ID, asset ID, and version error, abbreviated as GAV. So the thing here is that for RTF deployment, each application needs to be first uploaded to Exchange. Only then can the remaining flow be executed. Now assume you upload an app with group ID as com.mycompany, artifact ID or asset ID as demo app, and version as 100 snapshot. This will get uploaded. But the next time you upload the same app with some code modifications, it will fail because you haven't changed the group, asset, or version, which is GAV, and there already exists an app in Exchange with the same GAV, that is com.mycompany as group ID, demo app as artifact or asset ID, and version as 100 snapshot. So what you need to do is update either of this group, asset, or version so that it's unique and gets uploaded to Exchange. Alright, once the jar is uploaded to Exchange, the Runtime Manager sends a request to deploy the application. The Anypoint Platform Control Plane, upon receipt of this request, pushes a message to the queue to which the Runtime Fabric agent is listening to. Once the agent gets the message, it creates a Kubernetes deployment file and sends it to the Kube API server for further processing. Simultaneously, the agent will also create ingress resources for the app for external access. Once these steps are completed, a message will be sent back to the user via Anypoint Platform Control Plane with status as applying. Now note that in case if there is no ingress configured, the ingress step won't be executed. Now the Kubernetes will kick in action and start with the replica set. The replica set will in turn create pods. Now the creation of pods is a multi-step process. The pods for Mule application are multi-container pods involving 3 containers, namely init, app, and monitoring. The init container starts first and its job is to create the app and monitoring containers. The app container is where the Mule application gets deployed. Monitoring container is a sidecar that tracks the resources and other related metrics to be sent to the control plane. Alright, back to the flow. To create the pod, the init container image is retrieved from the Docker private registry, also known as image repo. Once the init container is started, it fetches the Mule application jar from the resource cache. The resource cache returns the jar if available. If not, it gets it from the exchange. Once the jar is received, it gets the image for Mule runtime and then creates a new container with the Mule runtime and the Mule app deployed to it. Next, it creates the monitoring container by retrieving the monitoring image from the image repo. Once the containers are created, the init container shuts down and you would only see 2 containers running in the pod. Once all of this is completed successfully, the pod should be up and running and the ready status is sent back to the user. And that completes the whole flow. So we have seen all the participants do something in this flow. But what about the last participant, that is the registry creds? Well, to access Docker private registry, also known as image repo, credentials are required. And this can be retrieved from the registry creds, whose job is to keep the credentials updated by refreshing them every 9 hours. Now, one important point. In this case, we saw that the user was manually uploading from the runtime manager. In case if you would want to automate, that's possible. All you have to do is add an additional step. So ideally, we use the Mule Maven plugin and we use the Mule deploy goal. But in this case, before the Mule deploy goal, you have to use the normal deploy goal, using which you can push the asset to Exchange first. Once it's published to Exchange, you have to use the Mule deploy goal that will help you to deploy the application to the runtime fabric. Now it's time to validate the steps related to the deployment flow that we just learned in the previous slide. So for that, I have created a very basic Mule app which has a listener listening to port 8081. If I show you the config, it's on 8081. Then it's doing nothing but just log the request received and sent log. And there is a basic transform which is having the JSON with hello as the key and world as the value. Let's move to the pom.xml. And this is the GAV that I was talking about in the slides. So always ensure that this is unique for each new iteration of deployment. So for example, if I create a jar out of this app and deploy it, once I deploy, it will get uploaded to Exchange. But next time, if I do not change the GAV value, it might give me an error regarding the these values are not unique. So always make sure that whenever you make changes to your application, increment the version at least, depending upon the major, minor, major, minor, and patch. You can change it. For example, right now I don't have anything uploaded. This app is being uploaded for the first time. So in that case, I'll just have it as is. But as I move forward, make changes to the app, I'll make sure that I'll update the version at least. Alternatively, you can also go to Exchange and delete that asset altogether or that particular version of the asset. Another thing to note that in case if you are using a CI/CD pipeline and want to upload the Exchange via the MVN deploy, then make sure that to add the group ID, and that group ID has to be the org ID. Apart from this, you might already be aware that you need to add the distribution management and all those things. So these are few things that you should keep in mind so as to avoid the GAV error. Now I'll head over to the command prompt and create a jar. So it's simple. I can use the Maven command, mvn clean package, and I don't have any test cases, so skip tests, and this should be fine. Alternatively, you can use the export option available in Anypoint Studio. So the build has completed successfully. Now let's head over to Anypoint platform. Inside the platform, open Runtime Manager. In Runtime Manager, select the target as the RTF instance that you have created. I've given the name as VP Demo RTF app. Then I have a couple of tabs here. The deployment target, which has details related to the target where we are going to deploy. That is our fabric. Ingress, right now I haven't configured the ingress, so it's kind of grayed out. Then properties, if I want to add properties like environment properties and similar things, then I can add here. Then JVM arguments, if I want to give, I can give it. Logging, right now I haven't enabled log forwarding, so there's nothing much I can do here. Now, one important thing that Suppose you want to enable different log levels. For example, you wish to enable wire logging. So in that case, you cannot use the logging tab, but you'll have to use properties tab. And the format is like you have to enter logging dot level, and then you can enter the level dot, and then you can enter the package name like org dot mule dot so on, and the value should be debug or whatever the value is. All right, so that's about logging. It's slightly different than CloudHub. Now let's go to the deployment target. I'll cover this ingress as part of a video because I haven't configured it. Now here you can choose any of the runtime version. There's a list of versions available, so you can choose it among given in the list. Replicas is the number of instances of your app you want. So I just want one replica. If you want to scale horizontally, then you can use this replicas and increase the count accordingly. Then there is an option run in cluster mode. So if I select multiple replica, this option gets enabled. The idea behind this option is that if you have multiple replicas, like in this case, it's two. If that's the case, and you have applications like a scheduler, right? So it has to run only on a single node and not on all the nodes, right? So in that case, to avoid duplicate processing, you can enable it and it will run only on one of the nodes. So if you enable, that helps you. So that in that case, you can go in the studio and check the primary node only option. For example, if I go, so in case of connectors, which are basically listener or the source connectors, there is an option called as primary node. So if you check this, it will ensure that it runs only in primary node. But this is possible only in case the runtimes are clustered. If you do not select the clustered option, both runtimes are not aware of each other and both of them might process. So that will result into duplicate processing. So uh, that is the role of that run in clustered mode. Same option is available in hybrid, wherein you have clustered runtimes. So there are two options, right? Server groups and cluster. So that's the role of the clustered runtime. Now let's go back to Chrome. Okay. Now back in the browser, I'll keep only one replica. So this option no longer works for me, and that should be fine. So next option is enforce deploying replicas across nodes. So what it will do is it will ensure that the replicas are always applied, pushed on other nodes. So the node selection, in this case, the model that we have only two worker nodes. So the assignment of these nodes are random. So if you are assigning four replicas and you have only two nodes, right? So in that case, there could be a chance that three replicas are on one node and one replica is on other. So this option will ensure that you have one replica per node. Yeah, but in cases where you want four replica and you just have two nodes, then there's no option. It would be uh, there would be two replicas at least on one node. Persistent object store, right? I haven't configured, but you can try using this. I doubt if it will at all work, uh, but I'm not sure of this right now at this point. Then we have the deployment model. So it's rolling or recreate. So recreate means every time you make changes to the config, either properties or the jar or anything, it will stop the previous instance of your application. Basically, it will kill the pods and then it will recreate another pod. All right. But in case if it is rolling, the previous pod that was created stays until the new pod comes up. The point when new pod comes up and transactions are flowing through it successfully, it will stop or kill the previous pod. And basically, this is the model on which CloudHub works. So whenever you deploy an app, the older version continues running, and once the new version is up and some transactions are flowing, it stops the previous version. Next is the resource allocation. So these are pretty much the same basic things. Reserved CPU, how much CPU you need. By default, it takes 0.02. Right now, the max limit is 3.7. And then we have the memory, which is zero point 0.7. So the amount of heap space you want, that specifies the memory. Limit is 14.9. And so this is a reserved CPU, which means that minimum is this one, and it can burst until 3.7. So that's pretty much about the configuration that we have. Now we can upload the file and try to deploy the application. Now, before deploying or starting to deploy our application, let's first log into the controller node, and then we will check the logs of the agent, because that's where the things would start taking place, right? We have seen the very first is the agent who gets the request. So let's keep an eye on the agent logs. So let's first check what is the name of the agent pod. So kubectl get pod get pods hyphen all namespaces. So it belongs to the RTF namespace. So this is the pod name. Let me copy this, clear it. Then kubectl logs namespace is RTF, pod name is agent, and let me add -f so that it streams the logs. Okay, there is a format issue. Kubectl logs. It should be logs -f agent namespace is RTF. Okay, it's complaining that I have to specify one of the container since it's a multi-container pod. So let's specify the app container, and it has all the logs. And right now, these logs are streaming, so any change can be seen here. So if you see, there are a couple of cluster probes that are being sent back and forth, to the control plane. But the so this is all the health, right? We have seen that it runs a health check every like 5 minutes, and the status get posted on the endpoint platform control plane. Now, when we deploy the app, we should see some changes in the log. See, now since this is streaming, it keeps showing all of this logs. Now, let's go back to the endpoint platform and try to deploy the app. So in the platform console, I have selected the application file. You can either choose to upload it from as a file or from Exchange, but right now I haven't uploaded to Exchange, so I cannot. But once this app gets deployed, it will get published to Exchange. So the first step is to publish to Exchange. So after that, if I want to deploy the app with other name, I can always choose it from Exchange. So with this, we can click on deploy. But before that, I would also like to have a look at the calls that it is making, right? So what we can do is we can click on inspect and what traffic it is making. And here we should see the traffic, and we can always export whatever the request it's sending. So let me click on preserve logs, and then I'll export this logs. So this is also known as HAR logs, which is HTTP archive. Now let me click on deploy the application, and it should start doing. So it deploys, we should be able to see some changes. So right now it's uploading, but once the upload finishes, we should be able to see uh, in putty. Let's go back to putty. So if you observe, it's publishing the applying state and the app name is VP demo RTF app. Oh, it's progressing, right? Now it has published the applying state and it's doing further processing. So let's wait for a couple of minutes and let's see. So it is now showing the state as applied. Now let's see what is the status. So back in the platform, I don't have any logs. I guess I'll have to refresh. But before I do that, let me export this logs and we'll have a look at it. All right, I have this file now. Let me refresh this page. So after refreshing, I see that the app has been deployed successfully. And here is the configuration part. If I check this, it shows all the configuration. So this is the ID and when was it last applied successfully. So the number of changes that you do to the config, like adding properties or anything, those get reflected over here. Now let's go back to Putty and see if the pod is up and running. So I'll come out of this logs because it has successfully completed. Now let me clear the screen and again run the kubectl get pods. So if you observe, I can see the namespace. So this is the environment ID. I see the name of the pod and it says ready 2x2 status as running. So if we observe 2x2 means there are two containers in this pod. And if you remember, I said that there would be total of 3 containers. So the init container has done its job, started the two containers which are app and the monitoring container. And then we see 2x2. Now let's see on which worker it's deployed. So we can use the O wide flag. And if we see it's on node 203, which means it's on worker B. It has an IP address. So this IP address is the pod IP address. All right. It also creates one service that is the cluster IP service. So let's check that service kubectl get svc hyphen all namespaces. So this is the namespace that has been created and this is the service name. Its type is ClusterIP. So whenever you deploy an app, it needs to have a static private IP. For that, the Mule app always gets a ClusterIP. So basically this thing is done by the agent. When it hands over all the configuration, Kubernetes creates a ClusterIP service. If you see, this is the cluster IP and the pod IP will be different. This IP will internally map to the pod. The ports that are exposed are 8081, 8082 and 5701. To understand more about the ports, what we can do is we can describe the service. So kubectl describe the name of the service, describe svc, name and the namespace. So use the flag n and the namespace. So here is the description. It has the namespace, the label details, selectors. The type is cluster IP. Now this is the IP address, which is the static private IP. This is a cluster IP basically. Then the port and the target port. So port 8081 on this cluster IP would be redirected to port 8081 on the pod. All right, and the protocol you see is HTTP. Similarly, you have the port 8082 mapped to 8082 of the pod. Again, this is for HTTPS protocol. And then we have something, one different, completely different port, that is 5701. Different because we are already familiar of this port, which is quite similar to CloudUp, but we also have a new port which is 5701, and this is basically for Hazelcast, just in case if you want to create cluster of your apps. In that case, this port is kept open so that the runtimes can form cluster. Right now we haven't clustered this, so it won't come into picture, but when the runtimes are clustered, it will use Hazelcast behind the scene so that they are aware of each other and share the same state among each other. So we see that we have three different endpoints, one with port 8081, second with 8082, and the third with 5701. This is with respect to the service. Now, does that mean that you always need to deploy your application with port 8081 for HTTP and 8082 for HTTPS? No, that doesn't mean you always have to deploy with these ports. You can choose any of the port like 9000 or any, if there is no conflict, you can choose any port. The only thing is that with this static IP, you won't be able to access it because this service is not in our control. We do not create. The agent does this for us. So you can still continue using 8081, but that doesn't stop you from using any other port. All right. Now, talking about service, let's also explore the ways we can access the application, because services help us to access the app, right? So right now I am logged in as a root user inside the node. So I am on the controller node. Okay, now let's try to access the app. So what I'll do is I'll directly do curl lvk. Now you can also choose v or this. I'm just adding this for verbose and uh, skipping any certificate validation. Of course, that certificate validation is not there because it's HTTP, but you can also use this. Right, so the IP address of this service was 10.112.110. So I'll copy this and paste it here. I'll have to explicitly specify the port, and then it should give me the response. So if we see, it's working. But we have seen in the DNS video, right, that it doesn't work with uh, the domain. So let's try that out. Now I'm still inside the node, and let me try with the domain name. So we have seen that in the DNS video how the domain name is created, right? So the format is the app name, which is vp demo rtf hyphen app, then the namespace. So let me copy the namespace, dot svc dot cluster dot local. All right, and then the port number 8081, and let me hit enter. So it's saying could not resolve host, and that's quite obvious because there's no DNS, there's no kube DNS involved here, right? It's inside the cluster. So basically, since that kube DNS has that entry and it's inside the cluster, the node cannot access that DNS. It's the node is trying to access its own DNS, which is within the VPC that we created. So to access using this domain, I have two options. Since I'm using the appliance version, I can log into Gravity. But in case if you do not have the appliance version, you can log into the pod and try out this URL. Now, so let's try. I'll enter gravity space enter, and I'll run the same command inside Gravity. Let me use the verbose flag V and let's see if we get the response. Yeah, I do get the response. It's because that the DNS, which is kube DNS, is present in this cluster, right? And gravity is the planet container, which is part of gravity, is the root container, and on top of it, we have all the other containers, so we can access. Now, what we can try is we should try to access it using the pod IP. So let's run this command. I'll come out of gravity again. Kubectl get pods one hyphen all name spaces, and okay, I'll have to use O wide flag. So again, let's try out with the pod IP. So this is the pod IP. Copy this to curl hyphen v and http. The IP address port number is 8081, and I'm able to get the response. So from the node with the pod IP also I'm able to get the response. It's just that with the domain name, the Kubernetes provided domain name, I cannot access because DNS uh, is not having the entry and it's using some different DNS which is within the VPC. Now if you want to access with the domain name of Kube, uh, Kubernetes DNS, then you can alternatively use enter the pod and try to access that. Now, apart from this, you can also describe the pod so that to understand what all steps were performed and what are the volumes that are mounted. So to do that, you can always run a command kubectl describe pods, and you can give the name of the pod, which is this, the pod name, paste it, the namespace. Okay, so we should be able to see details of the pod. All right, so we see all the required details. So it starts right from here, gives the node ID, gives the start time, the labels that have been applied, controlled by all the details. What's interesting or important for us to see, you can always explore this, but you can check the events that we have discussed, right? The same that we have discussed in the slide, right? So it's first assigning the IP address. It's assigning this pod to the worker node, which is 10.0.0.203. So it has assigned, then it's pulling the image, the init image, got pulled, then created the container, started the container. Then it's pulling the runtime image. So it's MuleSoft Poseidon runtime 4.4, pulled the runtime image, created the container, and then it's saying success status, started the container. Then it is pulling the image for sidecar, which is the monitoring container. And then it created the container, started the container. And then finally it ends. But we see one warning, which is unhealthy, and the readiness probe failed to connect. So it might happen sometime that the readiness probe fails. So readiness probe is basically a script that's running behind the scene, and it works on port 777, 4 times 7, which basically responds with either 200 if it's healthy or not. If not, then it doesn't, replies with some other status code. So whenever it deploys, it runs a readiness probe. If the response is success, then it uh, gives the status as running. If it fails for some reason, it gives the error as uh, error. But in this case, it succeeded once and then it started failing for the, so for that reason we have the warning, but the app is up and running. Now you also have volumes here. So these are the volumes that have been mounted on for the container. Apart from this, you also have the limits, the data that we configured from the runtime manager, CPU limit, memory limit, and all those details. So you can always explore, but this was the main thing that I wanted to show here. All right. Now we have seen service, we have seen the described the pod. Now apart from this, we also have a deployment created. So we can use kubectl get deployments hyphen hyphen all namespaces. So here are all the deployments, and this is a deployment that was created vp demo RTF. Now similarly, we can also describe the deployments. So you have to run this command kubectl describe deployments, name of the deployment, hyphen the namespace. So this gives you all the deployment related configuration that have been used. The selectors, the replicas, one desired, one updated, one total. So we chose only one, right? Strategy is rolling update, then pod labels and all those details are there. The number of ports being used. So this has the cumulative details, and from here all other configurations get created, right? So it basically has all the details: namespace name, pod name, mounts, pod info. It will also tell you the number of containers. So in case if you're confused how many containers are there, if you want to find out, obviously you can do get pods and see the number of running containers, but init container doesn't appear there, right? So if you see, here is an init container, right? And the image details are there, and uh, the the number of mounts. So pod info, which is read only, MNT overlay, which is read write. Then other containers are also in the list, which is the app container. So see the readiness probe, it executes the readiness probe.sh, delay of 10-second, time out of 5, period 5 seconds. So it shows that success was 1 and failures were 3. So and then you have the different mount points where license is where the license is mounted, which is read only, overlay, read write, and all those details. You can always explore this. And the last one is any point monitoring. So from here you can find out that the number of containers that you can have in your pod. So this is a good place to start with. It has all the relevant details. Now, one more thing that we would want to do is let's enter one of the container. So, and see that what all things do we have. So let me just list so that kubectl get pods hyphen hyphen all name spaces. So in order to enter, so my target is to enter this container that this pod that I just created. So I'll use kubectl exec to execute. Then IT means interactive terminal. Then I need to give the pod name, which is this, namespace, which is this. And finally, I need a shell script. So bin sh. Okay. So it says that it's defaulting to container named as app because I did not specify the container name. So there are two containers, app and monitoring. It has defaulted to app. So if I do list and I can see all the list, let me see the present working directory. I am in OPT Mule. Now here I can see all the details. The first thing that I want to do is I want to do curl request on uh, the pod, the IP address, right? The IP address of the pod. So, but what was the pod? I think I do not have the pod IP address, so I'll have to come out of this. Exit kubectl get. Let me just copy this so that I can quickly enter. Get pods hyphen hyphen all namespaces and oh white. Okay, now let's enter. Okay, I've entered the pod now, and this is the IP address that I'll try to access. So curl hyphen v http colon 8081, and I have the response. So the reason why I've showed you this, I'm showing you this because right now we do not have uh, ingress configured, right? And since we do not have ingress configured, we can not use the pod IP to access. Uh, Sorry, we can use the pod IP. We cannot use the domain that is created by kubedns, right? So which is, sorry, what I had to show was curl v and the domain name. So http, what it is, app name, right? So app name is demo vp demo rtf dot svc dot cluster dot, it should be namespace. This is the namespace dot svc dot cluster dot local. Port number is 8081. So now I'm getting the response. So if you are on the logged into your node and you're trying with this the domain name, it won't work because you are uh, calling a DNS which is not within the cluster, right? So in order to do that, we saw that there were two options available. One option was that to enter gravity, but not in every case you would have gravity. And in such cases, you can basically enter the pod and can use this domain name. Otherwise, if you are thinking of using the IP address, you can directly use it. Otherwise, instead, you can just log into the container and you can use this method. All right, now inside the container, it's time that we explore things. So here you can see, let's go to the apps folder, cd apps. Let's list. So this app folder has the pretty standard convention. It's having the app and the anchor file that gets created. If we were on a hybrid model, we can easily uh, delete this to uninstall the app. Right now, here we cannot do anything because we do not have any root access in this container. So we cannot edit anything, we can just view. So if I do cd vp demo rtf app, I can see all the files that are required. All right, let's go back and let me mm, do a step before. So here at the root level, we can see multiple entry point. One is the Java entry point, one is the Docker entry point, right? So these entry points are the point where things start. So this shell scripts get called, and we see that we have the readiness probe, right? That we just discussed. So we can also check this, do a cat on this readiness probe. So here's the script. I think it basically has three options: mule not started, fail to connect, and non 200 HTTP response. And we have multiple cases based on that. What's important to look here is that it listens on port 7777. This is the default endpoint. And based on the condition, it can also call this endpoint. So it just does some readiness check, and then based on the response, it will display if the app is started or not. Apart from that, we also have the liveness probe, and I've tried to run a cat command on it, but I do not see anything in it. It's just blank, it's empty. There's no uh, data into it. So I'm not sure what's the role of this readiness probe.sh. But I hope you understood what's the role of the readiness probe. This liveness probe, it's basically empty. So not sure what is the point of that file. Okay, so now let's go back to the folder where it all started. So we were in OPT, then Mule. Now in here, if you override any properties, right? So where do they get stored? So in this deployment folder, there is a YAML file which has all those details. So we can go there and check deployments, and herein you have the conf folder, and this is the file. So if we just open this vp demo rtf app.yaml, you can see all the details. So in case if there were any properties that we have overridden, would have come from here. Right now there aren't any, so it's not coming. So it's you can always go and check in this once you're logged into the container. All right, so now let's exit out of the container. And one more thing that we need to check is check the logs. So always you can use this kubectl. First of all, I don't remember the namespace name, so I'll have to do get pods hyphen all namespaces. I personally don't like the way the namespaces are created. It's quite difficult to remember. I mean, even type it, so you always end up copying this. So, but that's how it is. We can't complain much on it. kubectl logs name of the pod namespace environment, and then you can give the container name. So the container name has to be app, and if we see all the logs have come up here, right? And since we triggered a couple of requests, we see request received, response sent, request received, and response sent. So this is how you can enter uh, the server and check multiple things. So right now we do not have any log forwarding configured, so we always have to log into the node, and then this is the only way we can check the logs. Now, if you remember, initially while deploying the app, I downloaded an HAR file, which is HTTP archive file, which has all the details. So you can use this Google Chrome extension. It's called as HAR Viewer. Once you install it, it looks something like this. All you have to do is just load that HAR file, and then in the inspect section, you should be able to see something like this, which gives you what the calls are made behind the scenes when you click on apply button, right? So what's important to us is to see the two steps, right? First, we saw that it publishes the asset to exchange, and then it sends a message to deploy. So observe the first this request. So it's making a call to AnyPoint Exchange just to check if there is any asset available or not. You can have a detailed look by going through the response and request headers here, but this should give you a fair idea. It got a 200 OK, which means that the asset is not present. We can upload it. You can ignore the other ones. This is irrelevant, at least for us. Then it makes a post request to the exchange with the asset. and it took around 15.82 seconds. So it has a detailed view like what was blocking, sending, waiting, and all those things. Now let's expand this, and here also you can see request and response. And in the post you can see the data that was sent in which format. And in response, you can see once it's uploaded, it returns you a response with the required details. Once the upload was completed, uh, it makes another call, which is the deployment call. Right now, in this deployment call, it basically tells the platform that it has to uh, deploy the application. So it's AMC, right? Endpoint Management Center. It goes to it and just makes the call. So it's a post request with all details. So if you see name of the app, labels, target, provider is MC. MC means Mule Cloud. The target is the RTF ID, and all the relevant details, the reserved space that we added, the limit that we added. Right, so all those details are there. So once you deploy, you get a response. The desired state is started. So it's not yet started, but uh, it gives you a quick response saying that this are the details that it has taken and it will respond back. So whenever uh, there is a final response, uh, it updates based on that. So in this also all this part is not uh, collected because I had stopped in between. But yeah, the platform, this UI will keep calling the API to get to know that if the apps are up and running. So this would give you, this validates our understanding that we had in the slides, right? First, it makes a call to Exchange, and then it makes a call to deploy the application. Now, the final thing that we need to see is the asset published on Exchange. So if you check the asset, I can see it in Exchange. Now, one important thing that you should know that whenever you search in Exchange, you won't find this directly. What you have to do is you have to add a query param with the value as type equals to app. The reason we have to manually add this because in types you don't see any assets or any options with the name as app. So you end up adding this type app and then you should be able to see the exchange that has been published. Now let's open this exchange. So here I can see the asset detail and I can also choose to manage the versions. Right now I have two versions, 101 and 102. So in case if you again want to deploy the same app with version 101, make sure that you just delete it from here with the option delete. So that's all what I wanted to show. And with this, we can conclude the flow deployment uh, discussion. I hope you found it useful. Thanks for watching.